Sometimes to find the error it's best to actually work out the correct answer, and you can see along the way what might have happened. So if we're working out the correct answer, well, let's find out. We got 20,000, and that is 100%. And then we want to decrease it by 5%. So let's work out 10% first of all. That's easier to do. That's going to be 2,000. And then 5% is going to be 1,000. So in fact, in 2020, she should have 19,000. I've just done 20,000 minus 1,000. I can see now what Jasmine's done. She's actually then decreased by 1,000 again. She's decreased it by 10% overall. So she thinks if you decrease by 5% and then by 5% again, it's the same as decreasing by 10%. But that's not true, because on your second one, it's 5% of your new value, not the original value. Or 5% of the original twice. So what do we actually have to do? We've now got 19,000. We need to work out. So 19,000 is now our 100%. We need to work out 10% of that, which is going to be 1,900. And then 5% is going to be 950. So we actually have to subtract that. And in 2021, if I do that, I'm going to be left with not 18,000, but 18,050. I'm minusing 1,000 and then adding 50 on. It's the same thing. So I can see it's not 18,000 because we're not taking off quite as much in that second year. And that's our answer. Okay, write down the formula for P in terms of N, where N is the number of years after 2019. To do it quickly, this is how you would do it with a calculator, for example. You would use a multiplier. So it would be your original value, 20,000. And if I want to decrease by 5%, well, what I've got is I've got 100%, I'm minusing 5%. I'm actually finding 95%. And to find 95%, which by the way is 0.95, I can just multiply by it. I can multiply by 95%, or I can multiply by 0.95. But if I'm doing it in the second year, I would then multiply by 0.95 again. In the third year, again, and what you end up doing is raising it to the power of the year. Okay, this is our typical sort of compound interest formula. Circle the graph that best represents the price. Well, this is the one that Jasmine was using, a straight line going down, taking 1,000 off every year. That's not what happens. Actually, we can see that we're taking off, we're taking off a fairly large chunk and then a smaller chunk. So actually, this is the one that makes sense. It goes down more slowly over time rather than picking it up over time. So that is our answer. By the way, actually, I was just going to stop, but this is essentially exponential decay. This is a classic graph for exponential decay, which is what compound. It's not compound interest here. It's compound interest, but we're losing money. And if you were gaining money, then it would look a bit like this. It would go exponentially increasing like